Howdy everyone, and welcome back for the Chapter 5 video tutorial where we'll look at a couple example problems. First, looking at how do we identify the type of compound. That's very important so we know what rules for naming or formula writing to use. We'll then look at some of the ones that usually cause some more trouble for students. We'll look at ionic names where we have to include a Roman numeral for a charge. And then we'll also look at writing some ionic formulas where we just want to make sure that things are getting crisscrossed for the charges correctly. All right, so let's go ahead and look at those. The key thing for identifying the type of a molecule is to look at the first thing in the formula, because we have three main possibilities. If the first thing in the formula is a metal, then right away we can say that's an ionic compound. We know that metal means ionic. If we look at the first thing and we see a non-metal, then we say, okay, that's going to be covalent, because covalent is two or more nonmetals. That would be the molecular. And then the third option, which isn't in this problem, but it's in the chapter, is if the very first thing in the formula is an H, well then that's how we write acid. So, first thing I see is H, it's an acid, I'll go to the acid rules. So that's what we're going to do here. There are a couple exceptions, not exceptions, but just semi-metals, sometimes a little bit iffy, where you say, well, it's a semi-metal. They're usually treated as molecular. Usually the problem will give you some extra context on how to name that. For these examples and the ones in the problem set, you're not going to have to worry about it. All right, so if we just look at these, we say, okay, for A, we have CS2. We would look at that and say, okay, the first thing is C. That's carbon. Carbon's a nonmetal. So because of that, it is molecular or covalent. I think we'll do the type first. We'll come back and we'll name all these just to have some extra practice. Next up, letter B is over here. That's Cu. That's copper. Copper's a metal. So right there, I know it's ionic. The next one, letter C, I see K. K is potassium. Potassium's also a metal. It's on the far left. So that will also be ionic. And then the last one here is P. That's phosphorus. Phosphorus is on the right-hand side. It's a non-metal, so that will be molecular. So in the problem on the homework, that's all you have to do. It's just say, hey, these are molecular, these are ionic, I'm done. We're going to do a little stretch goal here. We're going to say, let's go ahead and name these, because that's usually the step we're doing. We first figure out what they are, and then we know what rules to follow. So for this CS2, it's molecular, it's covalent. That means we use prefixes. So C, let me change colors real quick for the names. All right, C is carbon. And then there's two S's. S is sulfur. We change the N to "ide," but with there being two of them, carbon disulfide. For B, ionic, Cu is copper. Now, copper is a transition metal, so we don't know what the charge is necessarily, so I'm going to leave a space for parentheses. This is the next problem, really. And then we'll look at O. O is oxygen, so that becomes oxide. For ionic, we do not use any prefixes. Then to figure out this Roman numeral, the charge of the copper, I say, well, I don't know copper, but I do know oxide. Oxide's -2. That means the copper has to be +2 to cancel it out, one of each. Okay, so it's copper 2 oxide. For C, Ki, it's also ionic, so it's just the metal as is, so that's potassium. Oops, and a little bit better there. And then I is iodine, change it to ide, potassium iodide. All right, and then finally, PCl3, it's another molecular covalent compound. P is phosphorus, so we'll write that as is. And then Cl is chlorine, becomes chloride. There's three of them, so phosphorus trichloride. Okay, so the dark blue is what we actually we're asked, but a little extra naming practice never hurt anyone. All right, so speaking of that, let's go ahead and do some more naming practice. These, we're told, are metal or compounds that have metals with more than one possible charge, so we know that they're going to need Roman numerals to tell us that charge. All right, so when we look at this, we say, okay, Cr is chromium, so I'll just write chromium. Leave a space for the Roman numeral, and then, okay, Cl is chlorine, becomes chloride. And so in this case, you can say, okay, chloride, if I look at the periodic table, it's going to gain one electron, so it'll be -1. But there's two of them, so another -1. Well, that's -2. How do I cancel out -2? I need the chromium to be a +2. And if it's +2, Roman numeral 2 in the parentheses. That's all you have to do. Add up the negatives. What's the positive to cancel it out? All right, next one. Well, very similar compound, so probably going to be a similar name. It's still chromium. Still need a parentheses for the Roman numeral. It's still chloride. And now when we say, okay, what does it have to be this time? Well, chloride's still -1, but now I got 3 of them. So if I have -3 overall, that chromium has to be +3. And so we'll get a Roman numeral 3 right there. All right. Last one, SnO2. So Sn is tin. And while it's not a transition metal, it is one that has multiple charges. So like I said, in this case, it might be a little confusing just looking at the periodic table, but the problem tells us these are going to have Roman numerals. So we say, okay, it's going to have a Roman numeral. There's my parentheses. All right, now we have O. Oxygen becomes oxide. And we say, okay, well, what's it got to be? Well, oxide, we look at the periodic table, we said it's going to be -2. So we have a -2. Oh, but I have another -2. That adds up to -4. And so that means the tin has to be +4 to cancel it out. So that means Roman numeral 4, IV, tin 4 oxide. Right? Now, before we move on, I do want to do one extra problem because I've checked the problem set. Sometimes things sneak in where you have more than one metal, and I do want to do an example like that. So I'll keep with the chromium and the oxide there. Let's say we had something, put it over here, like Cr2O3. How would we name that? Well, we'd still say it was chromium. We'd still have a parentheses, and we'd still have oxide. But we'd say, okay, the oxide, 3 of them, -2, -2, -2. That whole thing is -6. Well, that means the chromiums have to be +6, but wait, there's 2 of them. So we say, how do we get 2 chromiums to add up to +6? Well, you take the charge it needs to be and just divide by how many metals there are. So in this case, there's 2 metal atoms, +6 divided by 2. Each chromium is +3. And so with 2 of them, we get the +6 we need. So that's chromium 3 oxide. So watch out. If you ever see there's more than one metal atom, you still do the same steps of, okay, what are all the negatives? What's the positive to cancel it out? But then split it up. So the +6 gets split in half. Each chromium is +3. That's how you would do that one in case it comes up. All right, last one, ionic formulas. A couple tricky things can sneak in sometimes, or just oddities. Because, we always say there's this one way to do it, and then it turns out chemists love to do things multiple ways. So we'll work on some of those tweaks. So for A, we have copper 2 bromide. That 2, just like we said, that means copper's +2. Bromide, we'd look up on the periodic table. It's -1. And I like to do this, honestly, on tests and quizzes. Just write the charges above the word so I know what I'm looking at. Copper, then would be +2. Bromide would be -1. When we switch those, right, do our crossover, that means we'd get a formula of CuBr2. We check for reducing. We can't, so CuBr2 is that answer. Right. Next up, we have potassium. So that's K with a +1. Hydroxide, this is one of our important polyatomic ions to memorize. It ends in "ide", so it kind of makes you think of an element, but hydroxide, very important, OH negative, right, -1. So when we do that switch, 1 and 1, it's one of each. So we'll just get KOH. Okay, and there's that one. Now this last one, sodium hydrogen carbonate, this is the one that I wanted to point out. You'll see this sometimes either as hydrogen carbonate, or you might see something like hydrogen sulfate or hydrogen sulfite. You're like, why is there this third word, right? All the names, if you look, all our names are two words, right? It's carbon dioxide, copper bromide, right? Okay, Roman numerals don't count, but it's always two words. Even the acids, hydrochloric acid, two words. But there's a third word. Where's it coming from? There's another way to write this, and it's known as bicarbonate. And the Master in Chemistry will accept either one. If say the word name here was the right answer, if a student typed in sodium hydrogen carbonate and that was the right answer, they'd get it. If they typed in sodium bicarbonate, they would get credit. These are equivalent. So just watch out for that. If you're like, hey, what's with this hydrogen thing? What it is carbonate, just do a little lesson here. Carbonate is CO3 minus 2, and bicarbonate is HCO3 minus 1. So this hydrogen is like an H plus added on to the polyatomic. It's still a polyatomic ion, just there's an extra H there. And that's what that bi means. Usually bi means 2. Here it means throw in an H plus. I don't know why, it just is. But same thing. Sulfate is SO4 minus 2. Hydrogen sulfate, or bisulfate, is HSO4 minus 1. So it just adjusts the H, it adjusts the charge. There you go. But either way, whichever way you want to look at it, you say, okay, sodium is sodium plus 1. Hydrogen carbonate or bicarbonate is HCO3 minus 1. We switch the ones across. Okay. Oops. NaHCO3. And, of course, because nothing is easy, this has another name that you're probably familiar with that's neither of these. It's baking soda. NaHCO3, sodium bicarbonate, baking soda. The soda comes from sodium. Anyway, that's it for Chapter 5. Hopefully these hints were helpful, and this last part was not more confusing than it was worth. But if you have questions, always come in for office hours, come in for tutoring center, email questions, and we'll get you the help you need. Have a good day, and I'll see you back for Chapter 6.